As our population grows, the world will depend on new, renewable sources of energy to meet its needs. With decades of expertise in feedstock, bioprocessing, and biofuel production, DuPont has answered the call with the development of a fully integrated process that converts biomass to cellulosic ethanol. This end-to-end production system is used in our Nevada, Iowa biorefinery, which will produce 30 million gallons of fuel-grade ethanol a year, with a licensing model that can be applied anywhere in the world. Here's how it works. It all begins with the biomass. The Nevada site will create ethanol from corn stover, the non-food cobs, stalks, and leaves that remain after harvest. The stover is collected from cornfields within 30 miles, 50 kilometers of the plant. However, this innovative supply chain can be applied to a range of biomass feedstocks to suit local conditions around the world. Stover bales are transported to the Nevada facility from storage locations in the local area. As the bales enter the biorefinery, they are ground into smaller pieces, the first step in ethanol production. In the pre-treatment stage, ground stover is subjected to high heat and chemicals, sterilizing the stover and preparing it for further conversion. The pre-treated stover is now a damp, granular material. In the saccharifier, proprietary enzymes and water are added to the pre-treated stover. This crucial step in the process helps to release the sugars in lignocellulose, which is much more difficult to break down than corn or grain. The enzymes convert the complex carbohydrates into simple sugars that can then be fermented into ethanol. The mixture is now called hydrolysate. The fermentation stage of ethanol production is similar to the process of producing wine or beer. Microorganisms are added to the mixture to convert or ferment the simple sugars into alcohol. At the Nevada facility, proprietary microorganisms are added to the cooling hydrolysate to enable the conversion of sugars to ethanol on an industrial scale. The fermented material is now called beer. After fermentation, the beer is pumped to the distillation area, where it will be distilled to create liquid ethanol. The beer is heated to release ethanol vapors. The vapors are captured and condensed, reforming the liquid ethanol. After a final drying and purification process, the fuel-grade ethanol is transferred to storage tanks. It will be denatured before being loaded onto rail cars and shipped to be blended into gasoline. You've seen DuPont's revolutionary integrated process for creating transportation fuel from biomass. But there is even more potential value in the co-products created during the production of liquid ethanol. After the ethanol is removed during the distillation process, the remaining mixture is called whole stillage. This contains lignin, a valuable source of energy. The stillage is processed and dried to create a granular biomaterial. This lignin co-product can be used in a biomass boiler to produce steam and energy. It may also be sold to coal-burning facilities to offset the use of fossil fuel. DuPont continues to research and discover new ways to harness the value of this renewable material. The DuPont biorefinery represents a revolution in renewable energy production. In fact, the biorefinery itself is a sustainable closed-loop system. The plant is optimized to make the most efficient use of water possible due to an innovative water recycling process during distillation. And energy is preserved through unique heat integration techniques throughout the process. Today, the biorefinery in Nevada, Iowa is transforming non-food feedstock into cellulosic ethanol, lignin, and other energy sources. The advancements started here will continue to create value out of locally sourced biomass in countries around the world. These biorefineries of tomorrow will keep finding new ways to reform feedstocks into the energy and advanced biomaterials required by future generations. Welcome to the Energy Revolution.